Consuelo mathletes. Okay, what are we doing today? Well, so far I've been giving you the equation and then you've been doing stuff to it, graphing it, changing its form, whatever. Okay, so what's happening today? We're kind of going in reverse. All right. Now, I'm going to give you information and you're going to write the equation of the parabola. But there's something I want to go back to before we ever start doing this. And I'm going to write some stuff down here. Don't write it down, just listen. Okay? So what happened with a line? Now, I'm not talking about parabolas here. I'm going to go back to lines. We had slope-intercept form. We had point-slope form. And we had standard form. And what I told you to do is always write point-slope form first. In other words, if I give you a problem and I say, write slope-intercept form, do you start with slope-intercept form? Nay, nay, says the horse. You start with point-slope form, and then you change it to slope-intercept form. If I say write standard form, do you start with standard form? Nay, nay, says the horse. You start with point-slope form, and then you change into whatever form you want. So what form you're being asked to write does not determine what form you start with. Well, it's going to be the same thing here. I can ask you to write standard form or vertex form, okay? Now, you don't necessarily always start with just one of them, okay? It all depends on whether you know the vertex or not. If you know the vertex, you write the vertex form. If you don't, you write standard form. That's it. Do you know the vertex or don't you? Okay? Now, what if I give you a problem and I say, write standard form, but you know the vertex? Well, then write vertex form and change it into standard form. And we did that, a couple videos ago. What if I give you standard, or what if I ask for vertex form but don't give you the vertex, or you can't figure out the vertex? Then write standard form and complete the square and change it into vertex form. Okay, so that's the thing. It does not depend on what form the problem's asking for. What it is what do you know the vertex or not? Okay. So here, write the equation of each parabola given these x-intercepts. All right, now I'm going to scribble a bunch of stuff here. Okay, and if you don't understand what I'm saying, don't go on with this video. Call me over. Talk to me. Okay? But don't write any of this down. Okay. Let's say I give you this. Y equals x squared minus 2x minus 3. And I say find the x-intercept. Okay, what do? The first thing you have to do is set 0 in for y, and then you factor. So it's x minus 3 and x. So this is not what you want to be writing down. I'm showing you what we've done before. And x plus 1. Then what do? You set, even though I've said you may skip this step, and kind of please do, you set each factor equal to 0, and then you solve. Okay, so your x-intercepts are 3 and negative 1. Actually, it's 3, 0 and negative 1, 0. Okay? Well, what we're doing today is like the opposite of that. I'm going to give you or at least what we're going to do here at the beginning. I'm going to give you the intercepts. You're going to write the factors. So these, and then you're going to multiply them together. So these things are factors. They are the factors that give these x-intercepts, or I could also say for the time being, zeros. Okay? So let me just show you something. And don't write any of this down, just listen. What if I tell you there are zeros, 3 and negative 1? Okay, what factors would that give you? Well, we know the factor x minus 3 gives us an x-intercept of 3, And a factor of x plus 1 gives you an x-intercept of negative 1, right? So what would the zeros be? Well, first of all, okay, the factors would be x minus 3 and x plus 1, okay? Now, what if I told you the zeros or the x-intercepts were 5 and negative 7? Okay, the factors that would have given those are x minus 5 and x plus 7. Why? Because take a look up here on the top, the stuff I've scribbled. And don't writing this down, just listen. X minus 3 as a factor gave me 3 as an intercept, or a 0. X plus 1 as a factor gave me negative 1 as an x-intercept, or a 0. And if you don't get that, like, stop right away. Okay? Because if you don't get that idea, the rest of this isn't going to make any sense. All right. But I'm not going to talk about that anymore. All right? We'll use it quite a bit, but I'm not going to go into much of an explanation anymore about it. Okay? I'm just going to assume you know that, so if you don't, or you understand it, I didn't expect you to know it before now, but, just talk to me. Okay. Now, there's another problem, though. See, I've told, and don't write any of this down. I've told you in the past that let's say you had a vertex 1, 7. Okay? How many parabolas could, and this is not this problem, how many parabolas could you draw through that? Well, you could draw one going like this, you could draw one going like that, you could draw one going a little broader, you could draw one going a little steeper, broader upside down. There are an infinite number of parabolas I could draw through that vertex. And what's the only way they all differ? By the leading coefficient. Okay? Well, the same thing is true for knowing the x-intercepts. Let's say this is the x-axis. I'm not going to bother drawing the x-axis. And let's say I say the x-intercepts, and I'm just making this up, are 7 and negative 3. Okay, so we have 7, we have negative 3. Okay, how many parabolas could you draw through those x-intercepts? Well, we could draw one that looks, and again, I don't draw very well, but we could draw one that looks like that. We could draw one that goes upside down. We could draw one that's a little steeper. We could draw one that's a little broader. We could draw one that's steeper upside down. Hopefully you're getting the idea here. We could draw an infinite number of parabolas through those x-intercepts. What's the only difference? Some are steeper, some are broader, some are up, some are down. What's the difference? The leading coefficient, same thing, with all those different parabolas we could draw through a vertex. So, there's one thing that everyone forgets, okay? And that is the leading coefficient. All right, well, I'm going to go back to something. I've said here that you either write vertex form or standard form. Well, what's vertex form? It's y equals a times x minus h quantity squared plus k. And what's standard form? Y equals ax squared plus bx plus c. What do they each have? This, a leading coefficient. And everyone forgets to take that into account, okay? Take a look at the two forms. I don't care which form you're writing. What are the first three things you're always going to write? Y equals A, Y equals A, Y equals A. I mean, it doesn't matter what the problem is. If you're writing the equation of a parabola, it's going to be Y equals A. Then decide whether it's vertex form or standard form. Okay? So let's take a look at this. All right, first of all, do we know the vertex? No, we don't. So even if we did, it's Y equals A. Okay? But we don't know the vertex, so we're not going to write vertex form. We're going to write standard form. So what are we going to do? Well, We know the x-intercepts are 2 and negative 5. So what would the factors be that would give 2 as an x-intercept and negative 5 as an x-intercept? X minus 2 would give us 2, and x plus 5 would give us 5. Okay? Now, here's the problem, though. How many parabolas have those factors? An infinite number. Because there are an infinite number of parabolas that have 2 and negative 5 as x-intercepts. And what's the only way they differ? The leading coefficient, a. Okay, did I tell you, and so we've got to figure out what a is. Did I tell you anything about anything extra besides the x-intercepts that would help us to find the leading coefficient? No. So we're going to pick the easiest thing that we possibly can for the leading coefficient. Now, you can't pick 0 because that makes the whole problem go away. But the easiest thing you can pick is 1. Will it always be 1? No. But for this problem it is, because there's just nothing easier. Okay? So we have y equals, and you don't have to write the 1. We have x minus 2 times x plus 5. And now this doesn't look like standard form, but we just have to multiply it out. So it's x squared plus 3x minus 10. Okay? Now, I didn't ask for a specific form, so that's sufficient. If I did, if I asked for standard form, you'd leave it. If I asked for vertex form, you'd now complete the square. Okay, now what's happening here? Again, every problem is going to start y equals a. Do we know the vertex? No. So we know the x-intercept is 2 and negative 5. So we have x minus 2 and x plus 5, just like we did in the above problem. But the only difference here is I gave you something extra. I told you that the leading coefficient is 3. So you substitute in 3. And then you multiply it out. Now, something I want to point out. There are 3 factors here. There's 3, x minus 2, and x plus 5. Your brain, as I've told you before, cannot multiply 3 things simultaneously. It's impossible. You have to take 2 things, multiply them together, then multiply it by the third. I suggest you do the 3 last. So leave the 3 alone, multiply these, x squared plus 3x minus 10, and then distribute the 3. Okay? So here, in this first problem, actually, you could give me a bunch of different answers. You could let a, in the very first problem, you could let a be 1, 2, 1/2, negative 3/7, negative 41/8. It could be any number. I want you to pick the easiest one, and for this problem, it's 1. We'll get to other problems later where it's not going to be 1, but in number 2, you don't have a choice because I've told you what the leading coefficient is. So it has to be that. Okay. So given the x-intercepts and the graph contains 0.3, 1. Well, again, I don't care what you're doing. It's going to be y equals a. Okay. Do we know the vertex? No. Okay. All we know is some random point, 3, 1. So we've got the intercepts. So it's x minus 2 times x plus 5. Just like it was up in the first 2 problems. But here, once I give you something extra, okay, you can't pick what A is. Once you've fixed something else other than those x-intercepts, you have to figure out what A is, just like up here. I told you what A was in number 2. Here I didn't tell you what it is, but I gave you something extra. So what do? You plug in 0.3, 1. So where there's a y, we put a 1. Where there's an x, you put a 3. So that's 1 equals a, and this would be 1 times 8. So a is 1/8. So we have y equals 1/8 times x minus 2 times x plus 5. Now, this is not standard form, and it's not vertex form, but we're on our way to standard form. So what we do is, just like we did in number 2, we multiply it out. So we leave the 1/8 the way it is. we have x squared plus 3x minus 10, which is then 1/8 x squared plus 3/8 x minus 5/4. Okay? That's the only parabola that's given that has those x-intercepts and contains 0.3, 1. Okay. Now, vertex. So but you know what? Let's not even worry about that. Every problem starts y equals a. Okay? Now, we know the vertex, so let's write vertex form. X minus 2 quantity squared plus 7. Right? That's all vertex form is. Just like the amount of the shift. And the shift of this would be 2 to the right and up 7. Now, did I give you any extra information? No. So just like the very first problem, we can pick anything for A. You can pick, the word dog meat, I guess, if you really wanted to, but pick the easiest thing, and A here is 1. So we just have y equals, and I'm not going to bother putting the 1 because it'd be 1 times something is just itself. Okay, so that's it. All right, let's take a look at this one. So again, we have y equals a, just like every problem. We have the vertex, so it's x minus 2 quantity squared plus 7. Now, I can't pick the leading coefficient because I've said the leading coefficient is -5. So we have -5 times x minus 2 quantity squared plus 7. And you can just leave it like that because that's vertex form. Okay? That's it. All right, here, we know vertex. So, and even if we didn't, it's y equals a. It's always y equals a. And then we have x minus 2 quantity squared. And make sure you're squaring it. A lot of people forget to square it. Plus 7. Now, I didn't tell you the leading coefficient, but I gave you something. And once you fix something other than the vertex, then there's a specific leading coefficient. You can't just let it be anything you want. So what I'm going to do is I'm going to use 0.8 comma -4 and calculate A, just like I did up here in number 3, right? I plugged in the 0.3 comma 1, calculated A, and then put it in the problem. Okay, so here I have -4 equals A times 8 minus 2 squared plus 7. So we have -4 equals. Now, I'm going to show you the most common error here. It's A times 8 minus 2 is 6. Squared is 36. Now we have to solve for A. The most common error is people add those. Okay? But it doesn't say 36 plus 7 times A. It says 36 times A plus 7. So it's just a SADMET problem, right? Get rid of added and subtracted terms. We're solving for A. Get rid of added and subtracted terms first, so we get rid of the 7 by subtracting it. And we can write this 36A very simply. And then A equals -11/36. Okay? And now I'm a little short on space there, so I'll write the answer up over here. We have y equals -11/36 times x minus 2 quantity squared plus 7. So be very careful going from this step to this step, okay? It's not 36 plus 7. It's 36 times A plus 7. So you get rid of the 7 first, and then you divide by 36. Okay? And looks like that's about it. Fun and games. Okay, just something I want to mention here real briefly. This is sections 4.3 and 4.7. I think there's one topic of problems in section 4.3, and then there's another section, there's another topic in section 4.7. So you should make sure you do those, you pick those, just writing the equation of a parabola. Okay, have a good day, everybody. I hope you enjoyed this. Remember, y equals a, y equals a, y equals a. And then may you pick, oh, you know what? You know what? I should give you another problem because I just want to show you that a is not always 1. So I'm going to just throw another one in here at the end. Okay, let's say I give it to you here, given the x-intercepts. Let's say 5 halves and negative, 3/7. Okay? And I'm not going to tell you anything else. Okay, how's this problem going to start? Y equals a. And now these are x-intercepts, so just like it was up here, right, it's x minus the intercept. So this is going to be x minus 5 halves and x plus 3/7. Okay. And now I didn't tell you anything else, so what's the easiest thing to pick? It's not 1. Because notice, if I plug 1 in there and I have to multiply this out, it's going to be messy with a bunch of fractions. So what we're going to do is let a equal 2 times 7. Now, if you want to put 14, that's fine with me, okay? But why 2 and 7? Because that'll get rid of the fractions. So I'm going to say y equals 2 times 7. And I'm probably showing more work than you need to show here, but times x minus 5 halves times x plus 3/7. Now, what do? Remember, you don't distribute to factors, you distribute to terms. So I'm going to take this 2 and give it to the first one only. Then I'm going to take the 7 and give it to the second one. Why am I giving the 2 to the first one? Because that's the one that's got a denominator of 2. Why am I giving 7 to the second one? Because that's the one that's got a denominator of 7 somewhere. Okay, so what does that give us? That gives us 2x minus 5 times 7x plus 3. And then we'll multiply this out. So we get 14x squared, and notice that's the leading coefficient because 2 times 7 is 14. And I'm going to multiply this all out, but you should be able to do this in your head. Plus 6x minus 35x minus 15. Or y equals 14x squared minus 29x minus 15. So, it's probably not going to come up much in this chapter. I just wanted to point it out to you because, when you pick the leading coefficient, you want to pick the easiest one, the thing that makes the problem the easiest. And in number 1, just A was the easiest thing to pick. In number 4, I'm sorry, not A. In number 1, the number 1 was the easiest thing to pick for the leading coefficient. And in number 4, the number 1 was the easiest thing to pick as the leading coefficient. But I don't want to mislead you, so this is going to come up more later. One's not always the easiest thing, okay? And in this case, I'd prefer not to deal with fractions. So I'm going to pick 14, written in the form of 2 times 7, so that I can get rid of fractions. So I don't want to mislead you into thinking 1's always the easiest thing to pick. It's not. Probably for now, it might, I can't remember what the Alex problems are like, but you should be aware of the fact that it's not always the best thing to pick. All right, now I can say have a good day because now you know how to deal with fractions. And now your mathematical life is complete for the day. Have a good day, everybody.